Thanks again for joining us for today's webinar, Driving Automation and Efficiency with NinjaOne Policies. There we go. My name is Pete Breton. I'm the Director of Customer and Product Marketing here at NinjaOne, and I'm joined by Ethan Desmond, who can introduce himself.
Good morning, everybody. My name is Ethan Desmond. Thanks, Pete. I am the lead sales engineer here with NinjaOne. So my role within the company is to provide educational training as well as make sure that, as people utilize the platform and product, that they know where to go and what to do.
Awesome. Thank you, Ethan. Ethan has decided that he doesn't want to show his face today. He's ashamed and doesn't want to be seen on camera. If only we had IT people to help him with his camera, we would be in good shape. So we've got a couple slides today that we're going to go through. I try not to do death by PowerPoint, but there's a lot about policies to think about and to understand before we really dive in. So I do have some slides for you today. Ethan's going to spend some time in the platform after we go through those slides, really showing off the concepts that we're going to discuss first. So if you've been using Ninja for a long time, the first couple slides may be review. If you're new, they're definitely worthwhile paying attention to. And if you've never seen Ninja, I think it's a great way to understand how we do policies in a really differentiated and impactful way. Then we're going to talk about policy hierarchies. That's a fairly unique thing that we have where you can have policies that are root policies or parent policies and child policies that really allow you to dial in on the efficiency side of policies and make your job a lot easier and your management of devices a lot more standardized. Then we're going to talk about some strategies to actually get the most out of them, right? So we know different ways we can set up policies. Now let's focus on the best ways to do so. We'll take all that information, show you what that might look like in NinjaOne, and how to set it up yourself. And then we're going to end with some more tactical examples of conditions and scripts. Now, a lot of this is going to be strategy, the best ways to use policies and to get the most out of it. But we want to end with some real world examples of conditions and scripts, because when you first dive into Ninja and start using it, it's kind of a blank slate. And we want to give you a couple things to get started with so that you can go out and start building out your policies today. Now, if you're an existing Ninja partner and have been using policies for a while, this may lead to some work for you guys. If you're using it in a fairly flat or simplistic way, you may find that after this webinar, you have to go back and kind of rethink how you're doing policies. And that's what we're hoping to do, is to help you use them better. So I apologize for any homework this generates for you, but I think you'll get a lot out of it. So with that, the last thing I want to say before I jump into the content itself is please do make use of the chat and the Q&A. We want this to be engaging. We want it to be interactive. So if there's something in the moment that I'm explaining you need more clarification on, toss it in the chat. Ethan will let me know and prompt me to answer that for you. Or if you want us to go over something at the end, please do put that information in the Q&A. Last but not least, we do have another colleague, Christine, on the webinar here who will be announcing our gift card winner at the end before Q&A. So I'm going to go ahead and jump in. Oh, we've got someone from Antarctica. I think that person may or may not be telling the truth, but I hope they're telling the truth. That would be really cool. All right, let's jump in. We're going to start with NinjaOne policies, what they are. Again, for those who are NinjaOne partners, you're going to know what policies are, but I think it's important to level set kind of how we think about policies. So a policy is Ninja's centralized device management and automation engine. This is where you're going to spend time building out how you want your devices managed in Ninja. A policy contains things like what you're going to monitor for, what automations are going to run and how they're going to run and when they're going to run. This is where you set all of your patch management preferences. If you're using our built-in AV or security solutions, this is where you go in and define the utilization of those. And then finally, if you're using Ninja Backup, this is where you decide, what you back up, how frequently, and how long you retain it for. Ninja is a little bit different than some other endpoint management or RMM solutions in that you really have one policy per device. You can't have multiple policies applied to any given device. There's one policy that impacts the device and decides how it's managed. And that really gives you that centralized device management capability. Some others you'll have multiple policies applied to an endpoint or different parts of policy. You might have a patching policy, a monitoring policy, or whatever. Ninja decided on the one policy, one device scheme because we really feel it makes it more intuitive and allows you to centralize that device management and get more out of your investment in policies. Now, generally, you'll have many devices per policy, but again, one policy per device. So that's the basic definition, but it is worth spending some time just thinking about how much of your device management is really decided here. There are other tools in Ninja to help you automate and drive efficiency, like scheduled tasks, and you can do ad hoc script deployments, and you can use remote tools. But realistically, this is where you're going to get the most benefit if you invest heavily in NinjaOne policies. The next concept I want to introduce here is policy inheritance. For those of you who haven't seen policy inheritance in action, this allows you to create relationships between policies to create sort of like a parent-child relationship. And we only have 3 layers here. It's possible to have really as many layers as you want, but generally you might have something like a root policy, a parent policy, and a child policy. Or even just a parent and child policy, or root and child policy, however you want to say it. 2 or 3 layers is as deep as most people will go, but again, you can go as deep as you want. The way this works is that a child policy will inherit the traits of a parent policy. So if you set up conditions or scheduled scripts, or if you define your policy, your patching preferences in a parent policy, when you create that child policy, inherit from the parent, all of the decisions made in the parent policy will waterfall down into the child policy. We also give you the option to copy a policy, but once you do that, they're not connected anymore. So the new copy policy isn't really a child. It is just a copy. And so if I make changes to policy A, they aren't reflected in policy B. But with policy inheritance, anytime I make changes to a parent policy, they're going to waterfall down and be reflected in a child policy one step down. And you can see with multiple layers here how that can drive a lot of efficiency, right? You can, for example, add a script to a root policy and have it impact 10 parent policies and 20 child policies. That'd be an incredibly complex environment. But you don't have to redo that same work 20 times. You do it once in the parent policy, and it'll waterfall down to all of the children. Now, child policies can override decisions made at the parent policy or add additional traits in that child policy that the parent policy doesn't have, and those don't go back up, right? So if I'm at a child policy level and I add a scheduled script and then go to the parent policy, I won't see that scheduled script there, or the root policy, I won't see it there. So in addition, let's say I have a script running daily at 5 p.m. in a parent policy, I can override that in the child policy and make it 7 p.m. for that particular group of machines. That, again, doesn't impact the parent policy, but it does impact all of the devices that are assigned to that child policy. So everything is top down from root to parent to child. And then the children policy still give you that flexibility to override and add additional management capability to the devices that it makes sense to apply it to. As I've already said, inheritance does stack to multiple levels, and devices can be managed at any level of inheritance. So on this image here on the left, we can see that we have a root policy, and it's actually directly managing some devices. We have a parent policy and then child policy with these devices managed by different child policies. And then we have another one here with a root and child. So you don't have to have a clean hierarchy. You can have multiple hierarchies and devices at any level of that hierarchy. So it's up to you to define the hierarchy structure that makes sense to you. But the importance here is that you have the flexibility to assign devices at any level.
Hey, Pete. Matt Myers actually asked a question in Q&A that's relevant with what we're breaking out here. So can you associate a child policy with a new parent, or do you have to start from scratch each time on that end?
So the parent policy has to be built first. It could be empty. You could have a completely blank root policy or a parent policy. But whenever you go and create a new policy, any new policy, you have the ability to assign it to an existing policy and have that existing policy be the parent. Now, what you can't do is after you've created a policy, then go in and sign it as an inherited policy. So you would have to, like the child policy, you do have to start that from scratch to inherit it. I can't do a bunch of work on a new policy and then assign it to a parent policy. Let us know if that answers the question for you.
Excellent.
Awesome. So let's talk about device overrides next. And this is device and I guess policy overrides. You can override any part of the policy at the device level. So if I have my laptop here and it's super special because I'm just a little snowflake, I can override everything about the policy just to manage my device. Now that is absolutely not best practice, but there are instances where there are unique characteristics of a device, and so you have to override certain traits of a policy for individual devices. Let's say you have some old server that's constantly throwing, I don't know, performance errors or alerts, and you have a monitor for all of your policies to monitor for high CPU utilization, but you're getting this alert every single day. I may go to that server and say, I know this isn't a problem. I know it's going to throw an alert every day. I'm going to override that condition and not monitor that on this one device. So you can override individual traits or entire policies at the device level. You can also add additional traits at the device level. So if, again, I have a super special server and I need to monitor for a specific line of business application on that server, it's the only server in the world that has that line of business application. I can go and create additional traits for that server to monitor that line of business application is running or that it's installed or whatever it may be. It is important to know that overrides take precedence. So if I make an override at the device level and then the parent policy changes, let's say at the parent policy, I make a change to that condition. So the threshold on a CPU utilization monitor was 95% and I drop it to 90. Well, the override at the device level takes precedent and it's going to pretty much ignore that change to the parent policy. And so that those changes won't waterfall down for any overridden trait. Now, any non-overridden trait, those changes will still waterfall down. But if it is overridden, then it won't take effect on the individual device. So what you might see here is, for example, we have reboot daily at 7 p.m. That's a standard policy reboot option for all of these devices. And then we have a couple that we need to reboot at 11. That's a really simple example, but these devices have device level overrides so that they reboot daily at 11 p.m. instead. So Chris, that's a really good question. Chris asked if there are any easy ways to tell where policies are overridden. There isn't a report to show you this. You have to actually go into the device, and Ethan's going to actually show this when we do a demo. You have to go into the devices to see the overrides. And that's actually one of the reasons device level overrides are not best practices, except when you have to use them, because they're harder to manage. Now, it may be that we should create a report that shows you all of your policy overrides. I'll pretend I didn't say that, but maybe we should. But as of today, you have to actually go into the device, into the settings, and see that it is overridden, which is, again, one of the reasons it's harder to manage. Awesome question, Chris. Thank you. So now we're going to jump into policy hierarchies. I want to show you some examples of the policy hierarchies that we see most commonly in the wild, and talk a little bit about the benefits and drawbacks of each. So the most common one that we see is siloed policies. And I'm going to start off by saying, in general, this is not best practice. You essentially have 5, 10, 3, 4 different policies that are unrelated to each other. Each is managed completely separate within a role, right? So obviously your Mac policy and your Windows policy have to be different. But, let's say you have 10 different unrelated Windows workstation policies. This is a siloed policy, and they're unrelated to each other. And because of that, you don't get any of the value of having a parent policy, which is consolidated decision making, only having to make changes or improvements once. Anything that you want to do from one policy to another has to be duplicated. So if I add a new monitor to dental office client endpoints, I also have to add that same monitor to restaurant Windows workstations if I want it to apply. there's no efficiency of scale here. You're just doing each thing over and over again to build out standardization or to duplicate the work that you're doing. It also leads to a lack of standardization quite often, where, again, if I make an improvement to one policy, I have to physically go and manually make that update to others. And let's say you have, 5 technicians, and one's responsible for dental offices and another's responsible for restaurants. Dental office technician is going to make his updates to dental office, and restaurant tech isn't going to make updates to hers because she didn't know that there was a problem, right? So there's a complete lack of kind of standardization and a general lack of efficiency when you have your policies separated. Now, in really simple environments, this may work well, right? If all of your Windows workstations and laptops have the same policy, and you can manage your devices like that, this is great. This works fine. But in general, any complexity, any additional level of customization that might be needed, you're going to lose a lot of efficiency and standardization when you have these siloed policies. All right. Now, most people, when they start building out Ninja, they start here. And if they get too deep in before they find out about hierarchies and inheritance, you may get stuck here. You do so much work creating all these different policies that you kind of get stuck here. My recommendation is, after listening to this webinar, go back and think about how you can take some of this information and start building out kind of more complex policy structures that take advantage of the efficiencies and standardization that parent and grandparent policies will offer you. So here's example number 2 of using a global parent. This is still a pretty flat hierarchy. You still have, in this case, we have all our Windows workstations, and we have shared use laptops, workstations, and kiosks as our child policies. But this could be Windows workstation client A, B, and C. It could be Windows workstations and laptops, marketing, sales, and finance. The exact use case doesn't matter here, but having that parent policy is going to drive a lot of efficiency and standardization. So in this case, what we're doing is we're actually doing as much of our work as we can in that root policy, the Windows workstation policy in this case. We're going to put, all of our conditions there, all of our scheduled scripts. We're going to have, our default patching policy, our backup plans are all going to go there. And we're going to do all of the work there. And then we're going to make customizations and adjustments at the child policy level. So because of that, we're reducing the amount of work we have to do because we do it once and then it waterfalls down. We're still getting the customization and differentiation that you need to actually manage these devices by differentiating at the child level. Even if you don't create new traits, even if you don't make major changes there, you can manage the devices more effectively by knowing, these are shared use devices, these are kiosks, etc. You also you're going to duplicate the work as you go down. So again, I do it once at the top level, and I don't, the juxtaposition here is, if I didn't have that parent policy, I'd have to create each condition for shared use laptops and kiosks. I'd have to create each script for shared use laptops and kiosks. In this case, I'm doing it once, and I don't have to do it again. And that's, over time, a lot of efficiency that you can gain. You're also, again, going to have standardization. You know that you're monitoring for device uptime for all of your devices. You know you're monitoring for certain services. You know that your automation to restart services is applying to all of these. Even if it's not super relevant in some cases to one, the work you've already done just means it's going to be there in case it does become relevant. This is best for environments that benefit from flexibility and standardization, which can drive, most of our partners to using a structure like this. This is a really common structure, especially among our mature partners, that they use to get the benefits of our policies at a really, really high level. The one kind of potential problem here is that exceptions at the policy level or overrides at the policy level can cause scaling issues at really large and complex organizations. In general, we don't see those scaling issues, but they can happen. And that leads us to the next version here, the multi-layer version.
Hey,
yes.
really quick. So James had a question around, is there a limit of endpoints assigned to a child level policy? There is not. Just wanted to break that out. And then also, is role-based access manageable down to the child level? So when it comes to your technician roles, you can get granular as far as what policies they have access to on that side. Just to break that out.
Yep. And David's question, this looks like multiple policies applying to one device. So, David, in this case, the Windows Workstation policy, this top-level policy, isn't device-facing. It could be. We could have devices managed directly by this, but in this specific example you see in front of us, the shared use policy is the only policy, because we have one policy per device. The shared use policy is the only policy that impacts WLAB01, WLAB02, etc. Laptop/workstations applies to eDes Laptop 1, pBreton Laptop 1, and Kios applies to these. So this top level one is impacting the policies, but doesn't directly impact the devices. These actually do the management. Awesome. So now we get to the multi-layer version. This type of setup can add a little bit of complexity to management because you have multiple layers, but it can also add a great ability to scale. So I'm using a server example here. This is a real world use case that one of our customers actually shared with us that as being very effective, and so I wanted to share it with you. They have two types of servers they manage. They have the unmanaged servers, and really those, they just collect data. It's inventory data, but they're not responsible for managing those servers. Then they have another set of managed servers. In this case, they've broken it out into cloud-hosted VMs and physical servers. And so you have multiple layers here because you have a lot of different use cases. I'm going to go on the managed server side, for example. Our cloud-hosted VMs have very different things that we want to monitor for and automations that we may want to run as compared to a physical server. And so on the unmanaged side, we have some basic like data collection, maybe some conditions. We're just keeping an eye on things. That way, if we're asked to support them in an ad hoc fashion, we have remote access to them. We know what's going on with them. We know their status, right? We're just doing basic data collection there. On the managed side, though, we're patching, we're deploying applications, we're providing managed services, whatever it may be. And so we have very different needs. Now, some things may apply across the board. Even on an unmanaged server, we may want to know if a device hasn't rebooted in 30 days, for example, like we would on a Windows managed server, for example. And then again, comparing a VM to a physical server, like I may not care about, CPU temperature, or I may not care about chassis intrusion on a VM, whereas I might on a physical server. So there's a lot of potential overlap, but there's also a lot of potential differentiation here. And so in this case, you may use this to, again, build out all of your work at that root Windows server level, but then actually consolidate decision-making at the parent policy level. So for example, if everything's turned off at the root level, I may turn a bunch of stuff on at the Windows Server managed level, and then a couple additional things at the physical and cloud-hosted VM level to do additional automations and additional data collection at those levels. So I still have all my work done at root. I'm turning some things on at the parent level and then turning a lot of things on at the child level. And that way, each child policy I add under Windows Server Managed, let's say I add an exchange server, physical exchange server, or break out a policy for physical domain controllers. I'm getting a lot of efficiency by having stuff turned on at the parent level, the Windows Server Managed level, while still, again, having that differentiation at the child policy level. Again, we still have the benefits of the last one where work is automatically duplicated to child policies. There is global standardization because you're doing all the core work at the root level. And it is best for large, complex, differentiated installations. Yes, each device only has one policy applied to it. So in this case, Dell Backup 1 is managed by Windows Server Managed. DCO1 is only managed by physical server. But physical server is impacted by Windows Server Managed. I think this will be even more clear when we actually jump into the platform itself. But the traits that we create at the Windows Server level, the Windows Server Managed level, impact what's the physical server policy, but each device is only managed by the policy directly above it. Okay. Robbie had a question. Would you break this multi-layer down to different server roles too? Yeah. So in the real world example of this that I couldn't fit on here, they had, a DHCP server, a DNS server, an Exchange server policy as well. And so you could have a fourth layer, or you could just replace physical server with different server roles, for example. Awesome. Now let's bring it all together. So that was a little bit simplistic in showing like you may only have one hierarchy. You may have multiple hierarchies, right? So in this case, we have this multi-layer hierarchy for servers. For Windows workstations, our environment is a little bit less complex, so maybe we only have a one-layer hierarchy there. And then, this is supposed to say Mac. My apologies. And then for my Mac devices, they're all managed the same. And so we have a siloed policy here. I wanted to make it clear that in the real world, you might have multiple different hierarchies. Your server management might be really complex. Your Windows workstations might be a little bit more complex, but then Mac management is really simple, let's say. And so we could have different hierarchies for different role types. And that's kind of what you see here. And so I apologize. This should say Mac, but yeah, this is what a real world environment could look like, assuming you have a lot of server complexity. So let's go to where does it go? This is meant to be a simplified answer. There's obviously a lot of how to say this differently. This isn't meant to be directive, but to be helpful. And so you could argue about any of the things that are here. But in general, these are how we think about what goes in a root, what goes in a parent, and what goes in a child policy. And in many cases, you may not, you may only have two layers, right? So you could potentially drop this parent in the middle if you only have two layers. So what we recommend doing is actually doing all of your work at the root level. So if you have just two levels, or three levels, you do all of your work at the root level, add every condition, every scheduled script, define your policy, your patch management policy, look at activities and what you want to create tickets on, set up your backup plan, etc. Do all of that at the root level, and then turn it all off. If you don't have any devices managed by root, you can turn all that stuff off, and then turn it on at the child level. Now, if you only have two levels, if you have enough standardization, you can turn some things on at root. But in many cases, especially if you have three layers, you may want to have everything turned off at root and only turn things on at the parent and child level. Anything that applies to more than one device group, anything that's complex to set up, you do at the root level, and then you turn it on or turn it off or override it at the parent and child level. If you have three levels, the parent is really meant to coordinate decisions for policy groups. So again, going back to that server example, a parent, you might turn on 10 conditions and 5 scripts that apply to all of your physical servers. And so then every physical server group that you set up has those turned on by default, and then you do a little bit more customization at the child level. So this is really like middle management. It's just there to coordinate and drive additional efficiency at the child level. And then child, this is where you're going to enable device group specific traits. So if it's only impacts specific device groups or a specific device group, you're going to turn it on here. If there's anything proprietary to an individual client or device group, you turn it on here. You may even just create a new trait here. I do encourage you to do as much as you can in root, but if you can in child, if there are instances where you may want to create individual things in the child policy. If there are like stored credentials, you may want to do them here. And then like line of business applications that are only applicable to a small group of machines. Okay. I see a lot of chat going on. So let me know if there's something I need to address here. All right. Last but not least, planning for success. There are 3 keys here. Plan, then build, consolidate as much as possible, and standardize everywhere. The first one is probably the most important, especially if you're just getting started with Ninja. Step back, think about the best way to build out your hierarchies, recognize that those hierarchies are there to drive efficiency and standardization, and then pre-plan before you build. So, are your device-facing policies the bottom-most policies, the child policies? Do you have one per client, or maybe if you're an internal IT department, like one per subsidiary? Ninja does functional groups. So like sales has one, marketing has one, finance has one. We have companies that have, parent company and then subsidiary A, B, and C. We have some that are our MSP partners have a lot that are per client. You decide what's going to be best for you and where the differentiation really is, and then start building. And then secondly, we talked about a 3-layer policy or a 4-layer policy, but only do that if it's necessary and adds value, right? So do you really need a multi-level hierarchy? Make sure that you figure out what you're going to need ahead of time and then start building it out. Now, you can also have a super, you can start with 3 layers and just, ignore the middle layer or ignore the top layer, whatever it may be, to kind of create space for the long term, but only use as many hierarchies as you need, or only as many levels as you need. Did I misspell something here? Second one is consolidation is key. Invest in root policies. This is a big benefit or strategy that we've heard from our most mature clients, and that's do all of your work in that top level policy, that root policy, because the more work you do there, the more standardization you're going to get, the less you're going to have to redo work. And you can even disable all that. You don't have to have any of that turned on if it's not broadly applicable. You can use your child and parent, your low level policies to actually turn that stuff on and manage it more effectively. And then last but not least, standardize everywhere. Look at what you have today. Let's say you have 5 siloed Windows workstation policies, and there's a little bit different between them. One, do you need that differentiation? And two, if 80% of it's the same, you could go back, create a parent policy, reset up those policies, and put all of that work at the parent level, and even have 80% of it turned back on at the parent level. And that way you only have 1 or 2 things different at those child policy levels. We see that really often where most of what you're doing is standardized across clients or across endpoints. And so going back and creating those parent policies so you don't have to do the same script or condition over and over again is going to give you a lot of time back. Managing exceptions to policies is important. If you can take something from an override and put it into another level of child policy, that's going to, eventually that exception is going to come up again, and then you have a policy for it rather than going back and having to do device level overrides. And so wherever possible, minimizing those overrides and standalone policies will make you more efficient because they're harder to manage. All right. So I think to make this more clear, we want to see it live. I'm going to hand you over to Ethan, and Ethan's going to jump in and show you what some of this looks like in the actual platform.
Excellent. Thanks, Peter. Let me go ahead and share on my side. Okay. Excellent. And everybody can see my dashboard. Looks like it. So what we are going to be covering today is a couple of items. First of all, we're going to talk about new policy setup. We're going to break out inheritance. We're going to show some device level overrides, as well as, reinforcing what Peter has shown through the PowerPoint itself. We're going to show a complex use of grandparents to parent and child model policies. With that being said, we're going to go ahead and jump into the dashboard here, and we're going to first go to the administration section, and from here, policies. Within agent policies, what we're going to first take a look at in the top right-hand corner is create new policy. In this particular case, we will name this, if I can type today, webinar test, and we'll call this GP in this particular case. And we're going to select the role as Windows desktops and laptops in this particular case, and we're going to leave the parent policy empty, as this will be the top level. From here, we'll go ahead and save this in as broken out, and as Peter even broke out within the planning for success stage, and breaking out how you should handle your root versus parent and child. Again, these are not necessarily how you have to do it, but some methods for how you can break this out. So we're going to first do add a condition in the top left-hand corner. We have a variety of conditions for you to break out and set up your monitorings for. With that being said, let me go ahead and break out here. Awesome. CPU memory, disk monitoring, disk active. So what we could set up here would be like, let's say Windows Smart Status degraded. We'll get some additional monitors here. And then we also have some templates out of the box that you could always set up. So SQL Server, on that end, you could say 2016. Awesome. And now that we have these all set up within the grandparent policy or the webinar test GP, we're going to go ahead and disable these. The idea here is that what we can do is as we set up and enable other or create other policies within the policy section, we can enable these items such as high disk usage monitoring, TeamViewer services down, smart status degraded, etc. as needed within those child policies. So you're setting it up once and then enabling as you need. Now that we've gone ahead and plugged in our MFA, this item is now going to be saved, so we can close out here. And one question that came up was, if I make a root policy that has 42 changes or 42 monitors in it, and then add a child policy to adjust one of those, then I need to make the other 41 changes within that policy as well. So the idea here is, again, we'll say, in this case, we'll say webinar, we'll say child policy, we'll just call it this. Select the role, Windows desktops and laptops. And the parent policy in this particular case is going to be webinar test GP. And now here we can see all of the conditional monitors that we've set up are turned off. So to your point, if you were to have all of these turned off, or if you had them already turned on, you would just need to go ahead and do the opposite actions. So you would just turn these on. You know what? In the webinar child policy, we want to turn on print spooler services down. We're going to go ahead and enable Windows Smart Status degraded, as well as, let's say, the TeamViewer service and high disk usage. And just like that, we were able to make a child policy of the parent that has minor differences on that end. And I see here, is there a way to set a service recovery default behavior by policy? So on that end, you 100% could. So add a condition in the top left, select a condition. In this particular case, you would just do Windows service. And in this case, let's go ahead and use the print spooler, but it could be any other application service on that end or Windows service. Save it. And then now here, what you would just do is an add script. We're going to type in service. That service, sorry about that. So it would be your Windows service here. And then print spooler. And in this case, we can start. So what you have here is a full circle. If a service goes down, automatically start said service. Just to show what that looks like. And the idea here as well, and this is actually another great way to break out what you can do with child policies, is that now we've added the ability for the Windows Service Spooler is down monitor to start the service, but only within the child policy. So within that GP or grandparent policy, it would just be the Windows Service Spooler is down monitor. Excellent question, though. We'll go ahead and add this here, and we'll save and close. So that's the idea of breaking out a child policy from your grandparent. And then additionally, how we can break out here is you're going to have your overrides. So you have your, let's first find here, let's find a policy that has some devices in it. So our Windows Workstation policy. We're going to jump into here. We can see these three machines. We can go to this desktop 8LB. And then from here, we can go ahead and break out, go to overview settings. And from here, we can adjust and make a policy override. So this would be the third level. So you're going to have the root level, child, and then here you would have the device level. And then from here, this is where you could make adjustments to say, you know what? I want to go ahead and turn off some of these monitors. I want to go ahead and adjust my scheduled scripts. Maybe I want to have different Windows patching settings enabled at the device level from the child or parent policy on that end. Same idea with AV, activity monitoring, and so on, all through your policies. So in this particular case, we'll just go ahead and turn off this item here. We'll save this and close. And just like this, we're able to see, hey, we have 4 policy overrides created. And if we go back to the dashboard, administration policies, if we scroll all the way down to Windows Workstation, we can now see that we have a device that has overrides set up. And you can quickly click there to then see the devices that have overrides. Just to break that out. One question that I do see broken out a decent amount within the chat is going to be TeamViewer enablement. That is going to be enabled either at the organizational level as well as you can make adjustments on the per device level, just to break that out there. Okay. So
There's one question that's come up a couple of times that I want to address. Can you change?
Sid, Peter, you're breaking up a little bit. I apologize.
Oh, sorry. There's a question that's come up a couple of times here about changing parent policies. Is it possible to change which policy is the parent policy?
That is an excellent question. So on that end, there is not going to be a way to modify that, even by going up in the top left hand corner and modifying the policy name, or if you were to close out and then say go to webinar child policy. If we were to edit here, there's no way to adjust where it's inheriting from on that end. Excellent question, though.
Yeah, and so one of the reasons we set this up is because the more you invest in siloed policies, the more.
Peter, it still sounds like you're far away from your microphone.
Okay. One of the reasons we built this webinar was because the more you invest in those siloed policies, kind of the worse it becomes to go back and set up those parent policies. So, what makes sense to do is where you can go back and start building out this hierarchy now, because you can't adjust once you've invested in those siloed policies.
Excellent. Okay, so from here, what we'll go ahead and do is we'll break out some of the conditions as well as scheduled scripts. And with that being said, Pete, did we want to go ahead and switch over to, covering specifically around run one scheduled and quick access on that side, as well as your in-app alerts, notifications, and automations?
Sure. There's actually just one or two things more I want to share.
Excellent. I'll go ahead and stop sharing on my side.
So one of the real world examples one of the examples I showed in the deck that I wanted to walk you through is this Windows Server idea. It's that multi-step policy, multi-layer policy that I talked about, where we have a root, managed and unmanaged, and then we go down a level. So if I jump into root here, for example, I've got probably 30 different conditions I've set up. These are all of the different server monitors I might want to do, and I've invested pretty heavily in them, right? So even though it's at the server level, I'm monitoring the Active Directory service. I've got different notification channels I'm pushing to. I have a couple here that I think have, remediation. So DHCP services, if they go down, restarting those services. I've got VMware server monitoring. I've got a whole bunch of different things. You'd never have one server do all of these things, but I've invested and put my time into making these conditions at the root level and then turn them all off. Same on the scheduled script side. Again, you probably wouldn't do all of these on any given server. I wouldn't take a Hyper-V snapshot and then, okay, that's a bad example. And clear DNS, maybe. I don't know. Monitor for SQL backups. There we go. Probably wouldn't do those two things on the same device. But then when I go down a level to those managed servers here, you can see that I'm actually turning some things on, because on every managed server, I want to make sure that we're not overutilizing CPU, and that every device is rebooted every 30 days, etc. So I've got a couple turned on. I want to make sure that no one's being added as an admin, or no admins are being removed, etc. And then I go down one more level to, let's say, the physical domain controllers, and now finally I'm putting on those kind of role-specific things, like I'm turning on monitoring for the Active Directory domain controller services, and I think there's domain controller failed to validate credentials. So I start at the high level, I do all the work there, and as I go down, I add additional layers of things that I'm turning on and improving, so that when I get to this level, I'm not really doing any work other than checking and unchecking individual traits, but I'm getting the value of that differentiation. So I wanted to show that. And then Ryan asked about what happens if I delete a parent policy. So I've just created Windows Workstation delete test and Windows child delete test. So child delete inherits parent delete. And if I go into child, parent, they're the same. Everything here is turned on. So let's see what happens when I delete the parent. We'll do this live and see what happens. We have the this inherits delete test. So I'm going to delete this one here. My very professional email address. So I've deleted that parent. I'm just going to go ahead and reload here, and I'm going to come down, and it now inherits the Windows workstation, the parent above it. Uh, so it will go up one level. I'm not going to delete the Windows workstation because I actually have devices under that, but that's what will happen. It'll inherit one above, and if it's the most senior one, those traits will be hard coded. So that's an answer to that one. Awesome. Now we have two more slides. We'll be pretty quick on them. I want to give you some real world examples so that you can go and start building policies yourself if you haven't before. I'm going to go through conditions and then scheduled scripts, and then Ethan's going to kind of show those being set up. So I like to break conditions into three different use cases. There's just like the in-app alert. So, the little notifications in Ninja. Then you have notifications which are broader. Maybe you'd push those out to Slack or to Teams or to PagerDuty or to an email distribution list. They're things that you want to get out of the platform and make sure people are seeing. And then you have automation. Those are conditions that they're going to create an alert, but really the benefit is to actually kick something off. We detect something happened, and then we kick off an automation. So we have a couple examples here. You might want to just alert if there's like an account lock or if user permissions are elevated or if a server needs a restart. From a notification perspective, something bigger. We want to take an action. So, a RAID error or a backup failure or a server offline, those are things we may want to go do something about. And then automations, we have to actually be able to execute the automation for these to happen. But a really good example is restarting a service or rebooting end user devices, not servers probably, but end user laptops, and then maybe even installing missing applications. We have a partner who, for example, detects if Sentinel-1 isn't installed on their devices and then pushes it out and automatically installs it. Scheduled scripts, on the other hand, those are direct application of automation. Again, we have three different things that I like to talk about. One is that run once, things that we want to do to configure a device when it's first added to Ninja. And that might be things like installing applications or removing bloatware or adding or removing users or even basic data collection. On the scheduled side, those are things that we want to do regularly, right? So it may be writing some information to a custom field or rotating the admin password or deleting temp files. And then quick access is a kind of a unique use case. Adding them to the policy just makes them easier to find when you go to run an ad hoc script. And so we may want to do something like software deployment or data collection there as well. So I'm going to hand it back over to Ethan, and he's going to run through a couple examples of each of these. We're going to do maybe one of each so that we can answer questions.
Excellent. Thank you, Peter. Reshare on my side. Excellent. We're right back into it. It's over. Awesome. So to start off, as Peter broke out, we're going to first speak about in-app alerts, notifications, and automations on that end. So starting right off the bat, we're going to, in referring to in-app alerts, what we're breaking out is going to be, for example, here having your, hey, failed patches, as well as devices need to be rebooted, those types of items, as well as if we were to look into, say, Ninja Lab here at some of these alerts. These are examples of in-app alerts. For example, here, event ID 4738. A user account was changed. So in this particular case, what we can do is we'll jump into this device just to see which policy. So it is currently utilizing the Windows Workstation policy. And here we can go ahead and break out. So high number of failed login attempts. So this is referencing a custom field. So that is not a good example on that end. Here we go. So this is an example of a in-app alert to get for when a event Microsoft Windows security auditing is triggered. This is looking specifically for the Windows event ID 4625. And if the events trigger 3 times or more within 5 minutes, then you'd go ahead and get a in-app notification for that. Just like with your, pending reboots as well as failed patches, you would get that. Now, breaking this out even further, one thing that you could do and one thing that you could build out is, for example, let's take a look here. We'll just go ahead and add a condition, select a condition. In this breakout, we're going to have Windows Smart Status degraded. Now, this is an item that would be more so you'd want to get a notification on. That way, when you're coming back after a long 3-day weekend and it's that Monday, you're not coming into, oh, hey, look, the, executive assistant's computer is completely shot after a 3-day weekend. You're getting that email notification that you have smart status degraded issues prior to that. And how you would set that up is you can set it up to notify technicians based off of severity and priority, as well as a more recent Ninja feature that we've fully released, notification channels where you can have that go to specific emails, webhooks, so like a Microsoft Teams channel, SMS, as well as Slack channels on that end. So we have multiple ways for you to get notifications out of Ninja and into your hands. And then additionally, you have the ability to set up automations. Now, we'd already covered this a little bit in reference to the print spooler service, but the same idea, you can add a condition in the top left, select a condition, and then within this breakdown here, we'd say Windows service, we could do something like net logon. So if net logon goes down, what do we want to do? Add script in the top right-hand corner. We're going to type in service, and we're going to use the native Windows service script. And in this case, we just type in net logon again. And a question that does come up fairly often is, where do we get the list of services from? And that is going to be pulled from your devices. So Windows service net logon is down. What do we want to do? Let's go ahead and automatically start the service once it goes down after 3 minutes. And now you can always adjust that down to 1 minute if you wanted to make it more responsive and reactive. Outside of your conditional monitors, you also have the ability to set up scheduled scripts. So in this particular case, we have a variety. So run once, scheduled, and quick access. So in regards to the run once capabilities, a lot of our partners will utilize, so add a scheduled script here. And then breaking this out, you'd have your daily, weekly, monthly, run once immediately, none, every on system startup or on user login. So what you could do here is a run once immediately scheduled script that then would just go ahead and use the install application script to then push out your applications to your devices. So an example of a Ninja deployment and getting your machines ready to go for your end users would be get the laptop, throw the Ninja agent on it, and then have the run once action just push out, your 5 or 6 applications that you need or more on that end. Okay. I'm going to close that out. Additionally, you can also set up something like a scheduled script to reference a custom field. So in that particular case, we can go ahead and add a scheduled script. So we could do something like this, add script, and we could run a rotate local admin password. If we want to add any preset parameters and how we want to run the script as, you can go ahead and name it. And then this way you could tie it to the policy that's associated with all your devices that have the Windows Workstation policy either associated with them directly or through a child policy if you have it enabled on that end. You could say, okay, hey, let's go ahead and just run the script to rotate the local admin password on my devices. We have additional scripts that you could run scheduled. Another one that's very popular is like delete temporary files. A lot of people will tie that together with a condition, though, to say, hey, if, high disk use or, low disk free space, let's just automatically clean up the temp file folder. And then additionally, we also give you the ability through the platform itself. So outside of the policy at the device level, play button, you can run scripts on demand or ad hoc directly through the device. So from library, or you can run scripts that are already associated with your device's policy, like check failed logins, in which case we could kick that off. And then in the top right-hand corner, we'll see when that script kicks. So action started. And you can have that tied directly into custom fields as an additional note. So when speaking to and about, your policies and how you can break those out, you're going to have your in-app alerts, notifications, and automations on the conditional side, so monitoring. And then from the management or scripting end, you're going to have the ability to do run once actions, create scheduled jobs, as well as run quick access jobs as far as, like ad hoc data collection to custom fields, as well as software deployment by using a install application script ad hoc, if you'd like.
Awesome. Thanks so much, Ethan. I think we're going to pull Christine on to give out our gift card and then rapid fire answer as many questions as we can in 5 minutes.
Excellent.
Awesome. I'll keep it super short and sweet. Thanks, Pete. Hope we're all enjoying the webinar so far. I'm here for the fun stuff. So before we get into the questions, if we could all pop in the chat and say a huge congratulations to the gift card winner, Matt Myers. Congratulations, Matt. Be on the lookout for an email from me. I'll get that out to you.
Congrats, Matt. Thank you, Christine. All right, I'm going to answer these as fast as I can. I'm just going to run down because we only have 5 minutes, but here we go. The presentation will be recorded and shared with you. Christine will be sending out an email with the recording. It usually takes as much as a week, but we'll get it out as soon as we can. Number 2 from Mark Rossi, how can I monitor a device from only 7:30 to 11:30 a.m. EST, for example, because the device will be offline otherwise? We can't monitor just at specific times. You can alert at just specific times. You can actually go into your user information and turn off alerts outside of those particular hours, for example, but monitoring just at a specific time is not currently possible. Unless you want to enable maintenance mode every day manually, because we don't have recurring maintenance mode, there's no easy way to do it. Next question, can you associate a child policy with a new parent? The answer is, unfortunately, when you set up the policy, you have to assign the parent. You can't go back and reassign or assign a new one. And so anyone who's invested time in their policies, you can't go back and fix this. You have to build from the ground up again, which is a great opportunity to go in and standardize and review your policies, but it is additional work. So that's kind of the trade-off here is, is there enough benefit to going back and building out these hierarchies? My argument would be yes, depending on how many policies you have. But unfortunately, there's no way to go back and kind of assign parent after the fact. Policies cannot be assigned based on groups or locations. Policies assigned are assigned based on organizations. Let me go ahead and present really quick. So if I go into organizations and go into eCorp here, for example, and I go to policies, we have device roles. And when a device is added to eCorp, it will automatically be assigned to, for example, eCorp Windows for desktops and laptops and Windows Server root for servers. And you can change these. I believe the intention is to have location-based agent policies at some point in the future, but that is not available today. Let's see. What is the, all right, answered that one. If you delete a root policy and an organization is configured to use that root policy for all new devices, what happens? Do you happen to know that, Ethan?
I believe it should do the same. It should just revert to the parent on that end. So like what we were saying previously, where if you deleted the parent policy, it would go up a level, is it should revert to the Windows workstation role. If it's a workstation policy on that end, it should just go up.
Okay, awesome. Is there a way to schedule a script to run on Thanksgiving, for example? Yes, it's not policy related. If you go into admin and go to tasks, I can create a task here, and let's call it Thanksgiving Day Surprise, because running something on Thanksgiving sounds terrible. Good way to work on Thanksgiving. And we're going to, I am completely wrong. Oh yeah. I can turn off groups, run once. There we go. And I want to, I am wrong.
What you could do is try monthly on that end.
Oh, there we go.
Yeah, monthly, the specific day of the month, the time, and then you can say, yeah.
There we go. Thank you for that. And then I'd add my script here, and let's say it's, reboot all servers on Thanksgiving. Let's do that. And then I would assign the group, the devices that I want. So in this case, it's all devices in eCorp, or it's, this specific device, and that will run then. You would then want to go back and turn it off after the fact. But that's how you would do it. Awesome. We are at time, unfortunately. I apologize for not getting to everyone's questions, but I hope you got a lot out of this. Just to wrap up, I think, everything we tried to present here is kind of best practices and what we see working well in a lot of environments. There are caveats to everything we said. The important thing to do is to go and figure out the plan for your policies and your policy hierarchies, and recognize that you can get a lot of efficiency and standardization benefits by building hierarchies and leveraging those and doing your work at the highest level possible, so that you're not doing the work redundantly over and over again, which is redundant to say. And so the more you invest in policies and building policy hierarchies that make sense for your environment and working at a higher level to standardize, the more benefit you're going to get out of Ninja policies, the more automation you're going to get, and the more standardized your environment will be. And so with that, thank you all so much for coming. Ethan, thank you for presenting with me, and I hope the rest of you have a great day.
Of course, everyone have a great day.